Okay, so what if I told you we're right on the verge of building a computer that doesn't just, calculate things, but one that actually simulates reality itself? And no, this is not science fiction, this is quantum computing, and honestly, it's probably going to change everything.
To get a feel for what I'm talking about, imagine this. You're in a library, a massive one, with a million books, and your job is to find one specific word on one single page somewhere in that entire collection. Now, with a normal computer, you'd have to check every single page one by one. It would take centuries. But what if you could read all 1 million of those books at the exact same time?
And that right there, that's the fundamental difference. On one side, you've got the classical way of doing things. One reader just slowly plodding through page after page. But on the other side, you have the quantum library. And in this library, you have 1 million ghostly readers. They're not checking one page at a time. No, they check every single book, all at once. This whole idea is what we're calling the ghost in the library. And it's a really great way to start thinking about a completely new kind of computation. So you might be wondering, how do these ghosts actually find the word? Well, a quantum computer doesn't search in a straight line like we do. Instead, because it can exist in all possible states at once, in every single book, it can play with probabilities in this incredibly clever way. So when we ask for the answer, the system is set up so that all the wrong answers just cancel each other out, leaving only the right one. The result just appears, almost instantly. So how in the world does this ghost library actually work? What's the science behind this seeming magic? Well, it all comes down to the engine of the quantum world, the basic building block of this new reality, and it's called the qubit. A qubit, which is short for quantum bit, is where everything changes. You see, the laptop or phone you're using right now uses classical bits. They can be a 0 or they can be a 1. Simple. A qubit, though, a qubit can be a 0, a 1, or both at the exact same time. It's a mind-bending state called superposition. The best way to wrap your head around this is with a pretty simple analogy. A classical bit, that's just a light switch. It's either on or it's off. A qubit, on the other hand, is more like a dimmer dial. It can be fully on, fully off, and every possible shade of brightness in between, all at once. And that flexibility, that's superposition. It's what allows each of our ghosts to be in every single book at the same time. Now, if being in two states at once wasn't strange enough for you, there's another property that really pushes the boundaries of reality. It's a phenomenon so bizarre that even Albert Einstein called it spooky. We are talking about entanglement. So entanglement is when two qubits become linked in a fundamental way. Their fates are completely intertwined. If you measure one of them and find out its state, you instantly, and I mean instantly, know the state of the other one. It doesn't matter if it's on the other side of the universe. The connection is faster than light, which kind of breaks our normal understanding of space and time. And this is where the power just becomes truly, truly mind-boggling. One qubit gives you two possible states. Okay, but entangle two and you get 4 states. 3 gives you 8. See the pattern? The power literally doubles with every single qubit you add. Get this, with just 300 entangled qubits, you could represent more states than there are atoms in the entire known universe. That's how you get 1 million ghosts in your library. Now, this isn't just theory anymore. This is a massive engineering challenge, and there is a global race happening right now to build the first truly useful, large-scale quantum computers. People are actually trying to build the ghost library for real. And the race is definitely on. The top contenders are all trying different things. You have giants like IBM who are pushing for just sheer numbers of qubits with chips like their Condor. Then you have Google, which is focusing more on the quality and the precision of each qubit with its Willow chip. But really, they're all chasing the same holy grail, a system that's fault-tolerant, one that can correct its own mistakes. And the target for hitting that milestone, it could be as early as 2026. Okay, so a machine that uses ghosts, spooky connections, and dimmer switches. Why does any of this matter to you? What does a working quantum computer actually do for us? Well, the short answer is it changes everything. The real-world impact is going to be staggering. Think about medicine. We could simulate complex molecules to design new drugs in months instead of decades. But there's a flip side. Take cybersecurity. A powerful quantum computer could basically shatter the encryption that protects our entire digital world, from bank accounts to national secrets. And it could solve problems that are just impossible for us right now, like designing new materials atom by atom or figuring out global climate models. So at the end of the day, we have to understand this isn't just an upgrade. This isn't just a faster processor. It is a completely new way of doing things. We are building a machine that works based on the fundamental principles of nature itself. It's a machine that, as one physicist put it, speaks the actual language of the universe. And that just leaves us with one pretty profound question. Once we finally learn to speak its language, what's the first thing we're going to ask it?